Hi, this week is week 3. So today we are going to discuss about pre-lab experiment 2, determine the heat of reaction. So this experiment is related to our chapter 2, thermochemistry. So as usual, first you have to write down your name, class, metric number, lecturers, madam code for your lab report. Then the title of the experiment, experiment 2, determine the heat of reaction, and the objective. So there are two objectives, meaning that later you have to draw two conclusions. So the first objective is to determine the value of heat capacity of a calorimeter. And then number 2, to determine the heat of neutralization of hydrochloric acid and sodium hydroxide. So are you ready? Let's start. So before we start, right, actually you already watched the video through YouTube channel, Unique Chemia, KMPK. So you already get some idea about it. So theory for this experiment, first, chemical reaction can release or absorb heat. This can be measured by using a calorimeter. So what we learn is release heat is exothermic reaction. For the reaction absorb heat is endothermic reaction. So a calorimeter is a container that is thermally isolated from the environment. So we always assume that there is no heat loss when we undergo this experiment. Heat released by the chemical reaction is absorbed by the solution and the calorimeter. Okay, so this is the formula. Because it's heat released, there is a negative sign over here. Okay, Q is referred to heat. S is heat absorbed by the solution. QC is the heat absorbed by calorimeter. And the heat absorbed is proportional to the change in temperature. The proportionality constant C, capital C, is known as the heat capacity of a sample. And then heat capacity is defined as the amount of heat required to increase the temperature by 1 degree Celsius. So the heat released which absorbed by the calorimeter, we are using the formula Q equal to C delta T. For a homogeneous sample, such as solution, the heat absorbed is proportional to the mass of the sample and the increase in temperature. So proportionality constant, okay, this one is more small c, is known as specific heat capacity of solution per unit mass. The specific heat capacity for water with the value of constant 4.18 joule per Kelvin per gram. Okay, sometimes it's per degree Celsius, can be per Kelvin or per degree Celsius. Up to the reaction, if we are measure with Kelvin, then Kelvin. If measure with degree Celsius, then per degree Celsius. The specific heat capacity of a very dilute solution is equivalent to the specific heat capacity of pure water. Therefore, the value of the specific heat capacity for all solutions used in this experiment, actually in our syllabus as well, will be 4.18 joule per Kelvin per gram or joule per degree Celsius per gram. So before you proceed, right, you have to check for the constant, the least constant, okay? Heat that is being released or absorbed can be determined by measuring the temperature before and after the reaction. So this is the formula. For this experiment, the density of solution is assumed to be same as the density of water, 1 gram per cm3. So meaning that if the volume of the solution is given, we can know or determine the mass of the solution. For example, 100 ml of sodium hydroxide react with 100 ml of hydrochloric acid, meaning that total is 200 ml. Then 200 ml, if the density is 1 gram per cm cube, meaning that this solution total is 200 gram. Okay, now for the procedure, pre-lab, you have to draw the flow chart or the diagram in your lab manual. And then step 2, during lab, so there's no experiment, that's why this step, okay, cancel. And then post-lab, change all the steps in your lab manual to passive form. Okay, now result for part A. By right, you need to measure the empty calorimeter. What is the temperature? So this one is T1. And then once the hot water is added, so that one is T2. Until the hot water become constant, that one is T3. And then mass of water over here is 50 gram based on your lab manual. So since there's no experiment, so the value is provided by madam. So you just base on this value to perform the calculation and discussion. So the first one, T1 30 degrees Celsius. Okay, this is the result. Okay, for 120 seconds, means for 2 minutes. And then the T2 is 60 degrees Celsius. And then the T constant is 55 degrees Celsius. Part B, determination of the heat neutralization of 1 molar hydrochloric acid and 1 molar sodium hydroxide. So we have to implement this experiment for 2 sets, and then we take the average. So we measure the initial temperature for sodium hydroxide for 2 times. Okay, this is two different sets. So you are doing the 2 different sets. Okay, so you get A1, A2, B1, P2. Okay, this is the initial temperature for hydrochloric acid. Then you have to take the average initial temperature of a solution by sum of A1 plus B1 divided by 2. Next is the maximum temperature of the solution. You have to measure, and then the highest temperature, that one is T5. Okay, then the delta T by using T5 minus the average temperature T4, so this is the delta T1. Then we take the delta T1 plus delta T2 and divided by 2. So this delta T we get from the set 1 and set 2. We take the average. We take the average delta T. So no experiment, right? So the value A1, A2, B1, B2 are given. Then T5. Okay, both sets are given. So try to calculate the delta T by yourself. Calculation for part A, determination of the heat capacity of the calorimeter used. We have to know the heat absorbed by calorimeter actually is heat released by solution. So over here we are going to apply the C theta equal to MC theta. Okay, and then the delta T for calorimeter is T3 minus T1, and then for the theta for the solution is T2 minus T3. So you can refer to the value that given by Madam. Okay, so over here, right, we can substitute the value and then get the heat capacity for calorimeter. Remember, the unit is joule per degree Celsius. So you try to substitute and then get the answer. We are going to discuss next week. Okay, calculation part B. So first, define what is heat of neutralization. Heat released when 1 mole of water is formed from an acid react with a base under the stated condition. So over here, right, we know that heat released by the reaction is equal to heat absorbed by calorimeter plus heat absorbed by the solution. So the solution is acid and base, means HCl and sodium hydroxide. So heat is represented by symbol Q, reaction equal to negative because it's heat release. So heat capacity, delta T of the calorimeter, and then mass of the solution, and the specific capacity of the solution, and delta T. Okay, next we must know, right, we better write down the equation because over here we can check is 1 mole of sodium hydroxide react with 1 mole of hydrochloric acid and then form 1 mole of sodium chloride plus 1 mole of water. Because in this question, only the mole of sodium hydroxide and mole of HCl is given by applying the formula mV over 1000. Okay, then you can find the mole of sodium hydroxide and hydrochloric acid. So once you successfy the mole of both solution, then by stoichiometry, we know the number of mole of water. Okay, why we need to find the mole of water? Because according to the definition of heat of neutralization is 1 mole of water is formed. Okay, then madam give you some hints already. You will get 0.025 mole. Okay, but you still have to show the working over here, and then by using stoichiometry, you have to get the enthalpy of neutralization of this reaction and then make the conclusion. Okay, how do you get the 0.025 mole? Please show over here. Next discussion. Okay, you have to find the theoretical value of the heat of neutralization of hydrochloric acid and sodium hydroxide, and then you compare the value that you get from experimental. So the value of the heat of neutralization from the experiment has a larger or smaller magnitude than the theoretical. So is larger or smaller? You have to compare. This is because part of the heat, okay, Madam did mention at the early video, okay, during this experiment, okay, regarding about what? Okay, you have check. Okay, precaution. Acid solution should be poured into the alkaline solution Okay, what? During experiment, you have to pour the solution. How? And carefully. Then the solution should be, okay, what should you do during the experiment? When you added the HCl and sodium hydroxide, what are you going to do? Then the calorimeter must be closed tightly to, why you need to close tightly? Okay, to the surrounding or atmosphere. So the conclusion of this experiment, you have to redraw again. Okay, please mention what is the heat capacity of calorimeter. Don't forget the correct unit. And what is the heat of neutralization of this experiment in kilojoule per mole. That's all for this pre-lab discussion. So you can get ready your report according to this pre-lab video. Okay, see you all next week. Bye.